Okay, hi everyone. Thanks for joining us on the video podcast today. Today we're going to be talking about tips for handling, drying, and storing damaged grain. To start, my name is Christina Tabakhorst. I'm a field ag engineer with Iowa State Extension in Southeast Iowa, and I also have with me Sean.
Hi, I'm Sean Schaus. I'm the field ag engineer in Southwest Iowa. I've been with Extension for many years.
And so today we got some input from some folks on campus, particularly Charlie Herberg and Dirk Meyer. And we wanted to put together some sort of brief tips as there's a lot of grain damage that's pretty widespread across the state, whether it be from the derecho storm or maybe some drought stress. So we wanted to go through some tips on good practices this fall when we're working and handling maybe suboptimal quality grain. So we're going to kind of go back and forth here, and we'll just go through five major tips. So the first one is a big one, and it's really just to start off knowing your grain quality from the beginning. So especially this year, it's going to be very important. We want to know the quality of grain we're either trying to sell or we're going to try and store. So the big things we want to know will be if there's any mold on the ears or the grain, and also the test weight are going to be two big ones. And then within that, we know there's a lot of variability. So some fields have, within a single field, a wide variety of damage, a flat corn plant or just slightly leaning corn plant. So test weights might be very different. And we want to know what variability we have in that grain that we're trying to deal with. So again, test weights will be a big one this year with, photosynthesis was hindered basically when we have flat plants or plants shading each other. Grain fill might have been limited. So test weight's going to be a big one because that can be a good indicator of how well that grain is going to store for us, and how it's going to be graded, of course, in the market. Mold growth is another big one, and that could be whether it's drought stressed or wind damaged. Some of these molds could produce toxins under certain conditions, so be aware of that, especially if that's cropping up in your area. If some of those toxins are becoming present, we want to know they exist in our grain. But really, we want to know these, damage, mold, test weight, so that we know the level of risk when we're attempting to store this grain even. So we know that mold and toxins generally don't get worse in storage if we have done proper drying and cooling. So it's dried below that 15% moisture content or less, and it's cooled immediately, and we have good monitoring and aeration. So that shouldn't get worse in storage, but we want to know they exist. And then also that test weight is going to be a good indicator of storability. So when we're in test weights that are in the low 50s, that's going to be a good indication that we're going to have a hard time possibly drying, but also definitely storing that grain. We're going to have reduced storability. And some of the cornfields were totally terminated or flattened, killed from that derecho storm. And so some of that corn might be in the very low test weight range, close to maybe 45 pounds per bushel. So if we have that low of test weight grain out in the field, we really want to know about it. Maybe make adjustments when we're out picking that corn to maybe try and not pick up some of that very worst quality, low test weight grain. And also knowing that that's going to have a hard time, we're going to have a hard time marketing that very low test weight grain as well. So especially when that exists, we want to know about it because we know that we'll have to find the appropriate buyer. We want to know what the discount is. The buyer is going to dictate what the acceptance and the pricing is going to be, so they need to be part of the conversation when we're keeping up communication with our insurance provider. And we know that quality is an insurable factor, but it needs to be adjusted before it enters storage or before the elevator or the point of sale. So make sure you get a readjustment if quality changes, as weather might impact poor quality grain out in the field. And be sure you understand what quality factors are going to be part of your insurance assessment, whether that be test weight damage, possibly feed safety factors such as mycotoxins, things like that. So a big thing we're going to try and talk about this year is being good about sampling that grain, whether it be for your insurance adjustment, of course, but also before it goes into the grain bin. We want to know what that quality is. And the best method would be at the point of harvest, a tank sample. So we don't want to be taking ear samples, taking those in for analysis. We want to be doing at harvest tank samples. The very best way to do that would be to get a sample with maybe a PVC pipe sampler or a large coffee can or a large can on a pole or on a stick that we can sample through a stream of flowing grain so that we can get a representative sample. We're not getting in the tank where it stratifies and kind of sits differently depending on the quality. So all the way through that stream of grain, getting 3 to 4 samples is probably the best way to do it. If you have to just sample from the tank, a static sample, maybe getting multiple samples as the tank is filling a few different times as you're harvesting, so that we're not just getting one type of weight or broken material, things like that. And then if we need to do testing for toxins and things like that, the best method would be to send to a federal grain inspection service licensed grain lab for really the most accurate grading and toxin testing. But your local grain elevator should be pretty good at doing test weight, moisture, and possibly damage as well. So that's point number 1, is know your grain quality.
Excellent. Yeah, point number 2 we'd like to touch on is dry it quickly when the quality is low. Drying faster is going to minimize the risk of the grain spoiling before you can get it dried. So if you're drying this grain yourself, storing it on farm, this is not the year to rely on low temperature natural air drying for damaged grain. That's just a much increased risk factor there. So if you're using high temperature dryers, go ahead and turn that drying temperature up to the highest point that you can without causing additional grain damage. So look at the grain coming out of the dryer. If you're seeing some additional discoloration of the grain, wrinkling or blistering of the kernels, then you may have to back off a little bit on that drying temperature. But drying efficiency, energy efficiency is higher at higher temperatures, and the speed goes up dramatically at higher temperatures. So you can get it dried as quickly as possible and into storage. Then if you are looking for that temperature where the damage might start to happen, perhaps 160 degrees you might have to back down to if you're seeing some damage in the grain dryer itself. That the low quality corn, we're going to want to dry a little bit drier than what we would with high quality corn. So think about going 1 to 2 points lower in final moisture content than you would with high quality grain. That's because of what Christina already mentioned, that we know low test weight grain does not store as well even after it's dried as higher test weight grain does. So consider going just a little bit lower. Of course, you don't want to overdo that. That just reduces the pounds of saleable material, but go a little bit drier than you would with high quality grain, and watch that quality too. And then it's going to be really important to watch this grain closely while it's in storage, regardless of the temperature you use or the final moisture content. That is going to be really important to watch it closely. We know that low temperature drying works really well with good quality corn, but this year you want to just limit that low temperature natural air drying to good quality corn that's 21% or lower in initial moisture content. and have at least 1 cubic foot per minute of airflow rate per bushel with your natural air dryers. So use that only with the good quality corn and the right kind of conditions this year.
Okay, so tip number 3 is that cleaning, coring, and cooling are going to be essential this year. And they're important every year for grain management and storage, but especially this year with some variability in quality. So some of the big things, we really want to keep our poorest quality grain, some of the worst hit fields with lowest quality grain, lower test weight. We want to keep that separate from our better quality grain. Mixing them doesn't necessarily help the quality of that, that grain mass. So we want to try and keep them separate as best as we can. And when we have a variability in quality, let's manage it based on maybe the worst condition that's present, because that will go out of condition first. Coring these bins or cleaning, if you have a use for the fines or the broken material, you can clean that grain before you put it in the bin. But coring is probably one of the better options. This is the way we can remove some of that maybe lightest grain, the damaged grain particles, the fines, things like that, that could be potentially molded. Toxins are normally much higher in that core and where the fines are present. So we want to remove that for quality purposes, but also to level that grain surface a little bit better so that we have improved aeration and better cooling, so we can maintain uniform temperatures in the bin much easier. So when we core the bin, what we're looking for is to pull out enough that we've reduced that peak to more of a W shape. We've maybe reduced half the peak height where we see that W. That tells us that we've removed that core sufficiently from the center of the bin. And then also cooling. So get the grain cooled to below 40 degrees as soon as we possibly can. If you're harvesting earlier and with warmer weather, it's going to take a few cycles to cool that corn down. So every time we see a 10 to 15 degree drop in the outdoor average temperatures, let's run a cooling cycle and slowly cool that grain down. But take the chance to find times when our average temperatures are low or low nighttime dry temperatures to cool that grain. And also think about you can look at the dew point temperature as well. That's kind of an indication of how low we can kind of cool that grain. We can't get all the way to the dew point, but we can get somewhere between the outdoor temperature and the dew point temperature as we're cooling grain. And just remember the time to cool the entire grain bin depends on what airflow rate we have. So if we have a large drying fan where it's providing maybe 1 CFM per bushel, that could take somewhere around 15 hours to totally cool that mass of grain. But if we have just a smaller aeration fan closer to 0.1 CFM per bushel, that could take closer to 150 hours, almost a week. So we want to keep that fan on until we get the whole mass of grain cooled.
Very good. Then following that, once you've got that bin cooled down and you've cored it to get some of that lowest quality grain out of the bin, we're going to want to check this grain more frequently than normal. So we would recommend checking it weekly this winter during storage. And what you want to look for is any indication of mold growth starting to build up in that grain mass. That's usually the first sign that things are going wrong for quality. So smelling the first air that comes out when you turn the fan on gives you an indication of the air that was between those kernels. And if the mold growth starts to get significant, you can smell that. It'll get a musty smell, or in a bad case, it'll get a sour smell. As Christina mentioned, the amount of time it takes to flush that air out is going to depend on the airflow capacity of your fans. With a small fan, it may take several minutes to flush that first batch of air through the grain and out of the bin. With a big drying fan, that could be less than a minute. So in a case like that, you might need two people, one to be up at the access hatch on the roof and the other to turn the fan on, because that first flush of air may come out faster than what I could climb the ladder or the stairs to get up to that hatch. So keep that in mind, but smell that first flush of air for any indications of a moldy smell, a musty smell, or even a sour smell. Even better than trusting your nose is to use a measurement of the carbon dioxide level in that flush of air. As the mold starts to grow, it gives off carbon dioxide as it's consuming that carbon in the grain. And you can sense that with relatively inexpensive carbon dioxide sensors. You'll find those available for anywhere from $50 to $500, handheld battery operated CO2 monitors. You'll want to look for one that has an appropriate temperature range. If you're going to be using this in the winter, you don't want one that's made to only operate in air above 70 degrees, but look for the operating range. The accuracy isn't critical for this kind of monitoring. We're not interested in getting right down to the 1 part per million level. So the numbers we're going to be looking for here as you check that carbon dioxide level. Background in Iowa would be around 400 parts per million of CO2 in the air. Coming out of the grain mass, if it's under 600, that's probably fine. You'll get a little bit of elevated CO2 normally just in that grain mass. If it gets over 600, then we start to worry that there's more mold activity happening and insect activity in this grain than what we want. And certainly if it gets above 1,500 parts per million, there's significant activity, and the experts would say you probably need to get that corn out of the bin within the next few weeks if it gets above 1,500 parts per million on the CO2 measurements. So that's probably the best tool available and relatively inexpensive for monitoring what's happening in the bin. Again, aerate intermittently to keep that grain temperature between 30 and 40 degrees. We want to keep it cool. That minimizes insect and mold activity both. So take your opportunities to do that when the air temperatures are right through the winter, and just flush a little more air through there, make sure everything's staying in good shape.
Okay, so the last tip would be to not count on having long-term storage with some of this grain. So when we have damaged grain, mold damage, low test weight, if we picked up some of those higher CO2 levels when we're monitoring, we've stored it maybe a little bit too wet, things like that. We don't want to maybe try and store that grain past this winter, perhaps. So 3 to 5 months of storage in the cold winter months is probably okay, but we really don't want to try and hold it much longer than that. And you can use that test weight again. If you know the test weight in all your bins, use that test weight as a good indicator of which grain to get moved first as temperatures maybe start to warm up in the spring or before that. Use test weight as a good indicator of which to keep and which to sell first. We do know that the allowable storage time, the storage time before it starts to degrade in quality, it's definitely reduced in that low test weight grain. We don't have really good research numbers to tell us exactly how reduced that storage life is, but from recent findings from years with lower quality grain, when we're getting into the low 50s in test weight, that's when we know we might be somewhere around approximately just half the allowable storage life compared to good quality grain. So definitely don't want to try and hold on to that long. But again, that CO2 reading is going to be a better indicator of the real, the real time, what the quality is of that grain in storage. And then just one quick note, definitely having good aerated storage is going to be preferred over an unaerated, maybe temporary storage practice, such as, poly bags, grain bags, unaerated covered piles, things like that. Aerated storage is preferred. But, if we're able to get some corn dry right from out of the field, if we're able to harvest and put it in the bags and in cold temperatures, that might be a little bit less risky. We'll have cool, even temperatures in that storage. So aerated is preferred, but if we can get dry, cool grain in some of these temporary storage practices, that might be okay too.
So those are our 5 key points for managing this lower quality grain. There are a lot of additional resources available. You can go to the website listed first here for the Iowa Grain Quality Initiative, and there are links there to several other reference pieces and podcasts and videos with information about managing grain. You can also go to the Extension Crops page. They have a special page set up for storm damaged resources, and you'll see a number of topics there that are included under those resources about evaluating what you have, harvesting this grain that may be storm damaged, managing storage, drying, all of those kinds of things are included in those resources. The other resource we've included here is the Iowa Concern Hotline. We know that this has been a stressful year for a number of reasons, and harvest and storage of this grain is going to be more stressful again than a normal year. We know that this is putting a lot of load on the shoulder of farmers, and we want you to be aware that Iowa Concern is available. If you just feel like you need to talk to somebody who can help you manage all this extra pressure that you're under, and maybe help you deal with loved ones who are under a lot of stress, reach out to these folks. They have wonderful resources to help, and they know what it's like to work with folks who are under a lot of pressure.
All right. So I think that wraps it up. Thanks everyone for joining us today.